Hi everyone, I am Saurabh Kumar Singh and today I'm going to talk about the architecture field of system integration designs. So let's begin. Abstract. This paper introduces a measurement model for integration architecture validated through a industrial case study. It addresses the challenges of transforming legacy systems in large enterprises by providing a simple classification approach to compare integration designs, offering guidance on selecting the best fit for a specific use cases. The model helps identify problematic integration for refactoring and supports new integration designs based on requirements. Matrices like confidentiality, availability, integrity, flexibility, throughput, and latency are used to evaluate integration designs. Initial results based on real-world testing confirm the model's effectiveness, though further research is needed for refinement. To address this, the authors propose using software measurement to access the architecture feed of different integration designs, helping experts prioritize efforts and guiding less experienced teams towards effective design without requiring time-consuming in-depth analysis for each system. Methodology. The authors use a qualitative empirical approach to analyze the situation, conceptualize a solution, and validate it through real world observations. They begin by discussing the motivation for developing a measurement approach for integration architectures, driven by their professional experience and supported by empirical research. In section 2, they review software engineering and IT architecture approaches to create a taxonomy for classifying system integration and define matrices to measure their quality. Section 3 details the development of the measurement model, focusing on classifying integration technologies and scoring them based on non-functional requirements. In section 4, the authors validate their approaches through a real-world case study comparing the measurement result with observed strengths and weakness, while further studies are needed and the initial results suggest the approach is valid and useful. The paper concludes by discussing the experiment's outcomes, identifying strengths, limitations, and areas for future improvement. A result. The authors have worked out a clear taxonomy for integration architecture, segmentation, and classification and have also identified meaningful matrices to measure integration architectures by referring to established software measurement practices and standards. Based on this, the authors have described a measurement model that meets the desired case of use and has provided valid outcomes in context of the first case study. The application was described step by step to ensure transparency and reproducibility of result. Beyond that, what is described in this paper, the method was applied to two additional scenarios to further increase the robustness of the research outcomes and investigate the validity of the approach. In both cases, the measurement model provides plausible outcomes and help to improve integration designs. So this is the initialization of transmissions. Discussion. The current integration uses scheduled file imports where data is extracted from system A and uploaded to system B several times a day, and vice versa. This simple approach lacks real-time synchronization, causing workflows to pause until synchronization completes. Additionally, if data is updated in one system between cycles, one update may be overridden, compromising data integrity. To avoid this, certain fields have been made read-only in the system, but this reduces operational efficiency. File compilation errors can also corrupt data or cause integration failures. To address these issues, a redesign is needed, ideally with real-time synchronization using protective communication like web services or a database connection combined with periodic data saving for reliability during system unavailability. So this is the comparison of integration design based on architecture fit matrix. In this, on a y-axis, we can see architecture fit score, and in x-axis, there is the matrices. In blue color, the file import size has been shown. In green color, webhooks, and in orange color, change data capture has been shown. The first one is confidentiality, second one is availability, third one is integrity, the fourth one is flexibility, and the fifth one is throughput, and the sixth one is latency. Now conclusion. Concluding on research outcomes, the authors observe clear evidence that the proposed approach is valid and practical for efficiently modernizing integration landscapes. The first real-world application demonstrate that the models offer meaningful guidance for designing fit-for-purpose integration architecture are effectively measures the technical fit of integration designs. This contributes valuable insights to the enterprise's architecture and software measurement communities. The author developed a clear taxonomy for segmenting and classifying integration architectures, identifying meaningful matrices by referring to established software measurement practices and standards. Based on these insights, they created a measurement model that is easy to use and has produced valid results in the first case study. The step-by-step application ensures transparency and reproducibility. In addition to the paper's main findings, the method was applied to two further scenarios, strengthening the robustness of the research outcomes and validating the approach. In both cases, the measurement model delivered plausible results and helped improve integration designs. While the initial outcomes are promising and authors acknowledge the need for further refinement and maturation, addressing the identified gaps and weaknesses will be the focus of future research. So now this is the end of the video and hopefully it will be a little bit informative to you all. Thank you.